Molecular orbital theory is theoretical treatment to explain the formation of molecule or ion. How do we establish molecules? By combining atomic orbitals. Atomic orbitals themselves are wave functions. Those wave functions will interact, will mingle to produce new wave function, molecular orbital wave function. And after solving that molecular orbital wave function with the help of Schrodinger equation, we will get energetics of molecular orbitals. But to produce resultant molecular orbital wave function, we follow LCAO method. So with the help of LCAO method, which molecular orbitals we can establish, what are their energies, how can we distribute electrons in them, that we are learning for any two molecule. See, I am talking about any two molecule, neon molecule. Neon is a noble gas. So electrons are all paired. So it should not form any two molecule. That's our conventional understanding. Molecular orbital theory thinks about waves, thinks about establishment of various orbitals, then distribution of electrons, and afterwards if it results there is no bond, then molecular orbital theory will say bond order with 0. Let us see the application of molecular orbital theory to explain any two molecule.
Let us understand last homonuclear diatomic molecule, Ne2 molecule, as is included in your syllabus. Neon, a noble gas, 18th group element, atomic number 10. Electronic configuration 1s2, 2s2, 2p6. All orbitals are completely filled. How can molecular orbitals we establish? Because in molecular orbital theory we obtain various molecular orbitals, we understand their energetics, we distribute electrons in them, and then we describe the properties. 1s orbital of each neon atom, if I have to talk, then that is an inner orbital, and during the approach of those two neon atoms, appreciable overlap will not be there, and because of that we consider 1s orbital as non-bonding orbital. So as they were monocentric, likewise in molecule also they will remain monocentric, but they are the part of molecule. Previously they were the part of the atom. That only will be difference. Otherwise, in general sense, you consider molecular orbitals are polycentric. Then what about this 1s molecular orbitals or orbitals generated from 1s? Actually, those are not polycentric. We represent them as K and K. K for first shell means 1s, because in first shell only one orbital is there, that's a 1s. K for one neon orbital and K for other neon orbital, but those are not represented here. Actual molecular orbitals formation is shown in this diagram. Next, higher energy level orbital 2s. 2s orbitals of each neon have the same energy. First condition is fulfilled. They should be with the same symmetry. 2s from name we are going. But in spite of going blindly, let us apply the concept of our symmetry knowledge. If they are symmetric about the internuclear axis, bonding axis, cylindrical axis, then symmetry type is p. 2s orbital, spherically symmetric. Throughout that orbital, there will be plus or minus phase. If you rotate, there will not be any change in the phase. So what is the symmetry of 2s orbital? Sigma. So resultant molecular orbitals also will be with the sigma symmetry. Two atomic orbitals, if they are combining, two molecular orbitals will form. One bonding, one antibonding. Bonding orbital will be the result of constructive interference, addition of wave function. And antibonding orbital will be the result of destructive interference, subtraction of wave function. Bonding orbital will decrease in energy relative to the respective atomic orbitals. Why? Because overlap integral is positive. Between two nuclei, more electron cloud will be there. Electron density will be there more. Because of that, more attraction, more stability, decrease in energy. And what about antibonding molecular orbital? Overlap integral is negative, less electron cloud relative to the atomic orbitals, and because of that, nucleus can directly face each other, positive particle things, repulsion. Because of repulsion, energy will increase. So stability or instability? Actually it's instability. But the energy with which bonding orbital decreases, with that much amount of energy, antibonding orbital will increase. Here in case of the 2s orbital, I am talking about general approach. True approach is somewhat different. For that, little higher study you need to do. But if you are interested, you can go through the other video making sense for MO diagram for N2 molecule. Next, higher energy level orbitals are 2p orbitals. 3 2p orbitals are there. It's a triplet. All are degenerates. All are of the same energy level in atomic state. In molecular state, conditions are different. Let us understand those orbitals. Energies of all orbitals are same, so first condition, there is no question. They will form molecular orbitals. Symmetry is the most important thing. What is the symmetry of 2px orbital? We are considering 2px orbital as one lobe towards us and one lobe away from us. If you rotate that 2px orbital around the internuclear axis, then positive lobe will come to negative, negative will come to positive. So change in the wave function is there, change in the wave phase is there. It means it is not symmetric about internuclear axis. So what is the type of symmetry? Pi. Similarly, 2p orbital, up down orbital, if you rotate around internuclear axis, positive lobe will come to negative, negative will come to positive. So symmetry type is pi. And what about 2pz orbital? It is along z axis, along internuclear axis, along bonding axis, and if you rotate that pz orbital around that bonding axis, then there will be no change in the wave phase of the lobes. Positive lobe will remain to positive side, negative lobe will remain to negative side. It means it is symmetric about the internuclear axis. So what is the type of symmetry? Sigma. When we bring those two neon atoms closer, then which orbitals will interact strongly? Those are facing each other. Those are directly heading each other. Those are along axis. And which are those? 2pz. What is the symmetry of them? Sigma. So there's a strong interaction between the sigma symmetric 2pz orbital. Therefore, sigma bond can establish in case if any bond formation because of that interaction. Therefore, we say sigma bond is strong bond, because sigma symmetric orbitals are going to form the sigma bond. Then pi symmetric orbital, 2px and 2px, 2py and 2py, they will overlap laterally, sideways. So weak interaction is there, weak overlap is there. So stabilities of respective bonding and antibonding orbitals, so energies of bonding and antibonding orbitals also will be accordingly weak decrease, low decrease for bonding, low increase for antibonding. And for sigma kind of interaction, strong decrease, more decrease for bonding, more increase for antibonding. So if I have to talk total energy sequence in the orbitals, molecular orbitals generated from 2p level, lowest orbital is sigma 2pz, then pi 2px and pi 2py. Both will be of the same energy. So we say those are degenerate. Then pi star 2px and pi star 2py. And last, sigma star 2pz. Here pi 2px and pi 2py, since they experience equal kind of interaction, so decrease in energy is to equal extent. Similarly, pi star 2px and pi star 2py, increase in energy is to equal extent. Here for sigma 2pz decrease and sigma 2pz increase, we are finding the same, but true sense reality is different. To understand that intermolecular orbital interaction or interaction between molecular orbitals, you need to understand with the approach of symmetry. So for that I suggested one video at the beginning. You can go through that out of curiosity, but at your level now, this much MO diagram is sufficient. Now what is the energy sequence? KK, sigma 2s, sigma star 2s, sigma 2pz, pi 2px and pi 2py, pi star 2px and pi star 2py, and last sigma star 2pz. How can we distribute the electrons in them? Total how many electrons are there? 10 is atomic number of neon, so 20 electrons are there in first shell. That's the non-bonding orbitals K and K, 4 electrons are over, sigma 2s 2 electrons, sigma star 2s 2 electrons, 8 electrons are over in total now. So 9th electron will enter in sigma 2pz, 10th electron in sigma 2pz, 11th in pi 2px, 12th yes in pi 2py. Which principle is followed there? Hertz's rule of maximum multiplicity. 13th electron will pair in pi 2px. Following which principle? Pauli exclusion principle. Pairing is necessary there. 14th electron will pair in pi 2py. 15th electron in higher pi star 2px orbital. 16th electron in neighboring pi star 2p orbital, which is of same energy level. Which principle? Hertz's law of maximum multiplicity. 17th electron will pair in pi star 2px. 18th electron will pair in pi star 2py. 19th electron will enter in sigma star 2pz. And last 20th electron also will enter in sigma star 2pz. Can we find bond order for this Ni2 molecule? Bond order is equal to number of electrons in bonding orbitals minus number of electrons in antibonding orbitals divided by 2. How many electrons are there in bonding orbitals? 2 electrons in sigma 2s, 2 electrons in sigma 2pz, 4 electrons in pi 2px and pi 2py. Total 8 electrons are there. How many electrons are there in antibonding orbitals? 2 electrons in sigma star 2s, 4 electrons in pi star 2px and pi star 2py, and 2 electrons in sigma star 2pz. 8 electrons are there in antibonding molecular orbitals. So 8 minus 8 divided by 2. Answer is 0. Oh, means there is no bond between neon and neon. Means any two molecule does not exist. Number of unpaired electron 0. I mean as per MO diagram. So if you see this MO diagram, as per MO diagram, Ne2 is diamagnetic. In true sense, Ne2 is not exist. So there is no question of magnetic property. Then question will be with why are we discussing this MO diagram? See, if ion formation takes place, then to explain this magnetism and bond order, this MO diagram will come for your help. Therefore, we are studying MO diagram of Ne2. Same thing you can find for He2 molecule. Same thing for Be2 molecule. But we do study them. Why? For when ion formation, maybe cation, maybe anion, then this study helps. And that we are discussing O2 and ions formed by the oxygen molecule. Let us understand the representation of electron configuration for Ne2 molecule. Ne2 molecule in true sense is not existing, but theoretical approach and explanation by molecular orbital theory means we are validating molecular orbital theory. We are understanding the application of molecular orbital theory. Therefore, various molecular orbitals we are considering. About electronic configuration, first represent the molecule, say Ne2. Then 3 horizontal line means equivalent for electronic configuration. Then in special bracket I am representing various orbitals, molecular orbitals. Especially by green blue coloration I represented those non-bonding orbitals. First shell orbitals, 1s orbitals. Those are not truly molecular orbitals but are the part of the molecule. Those are not polycentric. 2 electrons are there in each orbital. So kk, total 4 electrons are there. Then sigma 2s, 2 electrons, sigma star 2s, 2 electrons, pi 2px and pi 2py, those have same energy. Those are degenerate. That is represented by is equal to sign. And each has 2 electrons. Sigma 2pz, 2 electrons. Pi star 2px and pi star 2py, as I discussed before, are degenerate, represented by equal to sign, and each orbital has 2 electrons. And last sigma star 2pz orbital has 2 electrons. Means as is the case for neon atom, all atomic orbitals which we are considering are completely fulfilled. Here in neon molecule, all molecular orbitals are fulfilled. And if such case occurs, bond order remains 0. Neon molecule does not exist, but it's a theoretical approach we are discussing. As a homework, very simple question. Does diatomic neon molecule exist? Means any two molecule in real exist or not? That you have to answer in the comment box.
Explanation of diatomic neon molecule, it doesn't exist, is also the very wise explanation given by molecular orbital theory. About magnetism means in case if it establishes, then magnetism is there. If it is not going to establish, then magnetism has no question. But whatever the prediction molecular orbital theory did, that's excellent. We studied now many homonuclear diatomic molecules. Now it is a time to understand few ions. We can obtain positive ion by removal of electron. We can obtain negative ion by retrieval of the electron by an atom or the molecule. Yes, we are talking about the ions formed by oxygen molecule from next part.